friction.
Next friction question. Let's do it. It's getting harder. This is going to be a tougher one. Might help you with some of the tougher questions that you are attempting in your problem set. So let's get into it. You are dragging a 110 kilogram trunk across a floor at a constant velocity with a horizontal force of 380 newtons. Okay, that's not too complicated actually. Maybe this question isn't so bad. So we've got a 110 kilogram trunk, and let's say it's being dragged to the right, and the force is 380 newtons. That's not a free body diagram. That's just, I guess, a system diagram, or I forget what it's called. Here's a free body diagram. We've got force of gravity, force of normal. These free body diagrams are getting kind of repetitive. You're probably starting to realize that a lot of these questions have the exact same free body diagram. The main thing to make a note of is the applied force greater than or equal to or less than the frictional? Well, it's never going to be less than the frictional force. Oh, yes it is. What am I talking about? Okay, anyway, the frictional force is there. Okay. And this is 380 newtons. So part A, calculate the coefficient of kinetic friction. That's pretty easy. So that's just mu equals FF over Fn. So I guess, oh yeah, it says constant velocity. I didn't even realize that at first. Constant velocity, that means the frictional force must be equal to the applied force. So that's 380 divided by the normal force, which is equal to the gravitational force. So that's 110 times 9.8. And so we should just be able to plug all that stuff in. I'm just going to do 110 divided by times 9.8. Oops, 110 times 9.8. And 380 divided by the answer. Okay, mu k equals 0.35. Remember, mu is always between 0 and 1. If you ever get a value that's not between 0 and 1, you did something wrong. So just watch out for that. It's a really good way to know that you're doing something wrong, if you're aware of it. Okay, part B. A friend decides to help by pulling on the trunk with the force of 150 newtons up. Will this help? Calculate the force required to pull the trunk at a constant velocity to help you decide. Yes, it will help, because remember the formula for the frictional force equals mu times the normal force. Well, how does this affect the normal force? If you've got a friend pulling up on the block, then you don't need as much normal force to counteract gravity. So the normal force will be less. Therefore, the frictional force will be less. So therefore, you won't need to pull as hard in order to keep the block moving at a constant velocity. So, okay, the normal force, I should have written it down from before. Well, let's do it like this. Let's do the gravitational force equals 110 times 9.8, which is 1,078 newtons. But now this time the normal force does not equal the gravitational force. Actually, the normal force plus the force of your friend, I guess, those two add up to equal the gravitational force. So Fn plus your friend's contribution, which is 150 newtons, equals 1,078. And so if I'm doing my math right, the normal force is 928 newtons. So therefore, the frictional force, and that's up, frictional force is, 0.35 was the coefficient, times the normal force, which is 928, .325 newtons. So you only need to pull with 325 newtons instead of 380 newtons. Okay, part C. Instead of pulling on the trunk, your 55 kilogram friend just sits on it. What force is required to keep the trunk moving at a constant velocity in this case? Okay, once again, this is just going to affect the normal force. So the normal force equals mass, which is 110 plus 55 times 9.8. So 165 times 9.8, 1,617. And frictional force equals mu Fn, so that's 0.35 once again, times 1617. And now this time you have to apply more force, so 566 newtons to the, well, that's the frictional force, that's to the left. So you need to apply that force to the right if you want to keep the box moving at a constant velocity.